or two different things that we're looking at. We're looking at the exponent of 0, and then what happens if you have negative exponents. So those two different parts. We've already talked about an exponent of 0. So on this first one, if we were expanding it, what would happen if we have it expanded? It all cancels, and so it all equals 1, right? But if it's division, what operation do we do with exponents when it's division? Subtraction, so it would be 7 to the 5th minus, or 5 minus 5, which is 7 to the power of 0. But we already know that it's equal to 1. So 7 to the power of 0 is equal to 1. Same thing on the next one. If we expand it out, they all cancel, meaning it's going to equal 1. And if we do the subtraction, it's the same thing. 3 minus 3, so it's really a to the power of 0. What's going to keep happening?
1.
It's going to, the same thing. These cancel with each other, so it's equaling 1. When they cancel out, it's equal to 1. Because it's being divided by itself. Anything divided by itself is 1. This is the only rule that's not on your formula chart. That anything to the power of 0 is 1. Go ahead and do 1 through 4. Do those 4 problems. Okay, once you do 1 through 4, I also want you to do example E, example F, and example D. So you have 7 problems in what you're doing right now. Alright, so for number 1 and 2, those are both 1 because it's just that one thing to the power of 0. What's the answer to number 3?
2.
Correct. The only thing with that exponent of 0 is n. That means this is really saying 2 times 1, which is 2.
Yeah.
So then what's the answer for number 4?
4e2t.
The only part with the exponent of 1 was n. So now let's go down to letter D. On letter D, there's something different in it as well.
4x.
Oh, so pay attention.
Wait, do you add?
You have x's in different places, more than just that one place.
4x.
So 4 correct. X to the power of 9. N has an exponent of 0, so that becomes a 1. So just cancel that. P to the power of 4. And then y has an exponent of 1, so that is also canceling out. So there is our final answer. Now let's look at E. We are simplifying some stuff. What operation is happening with E?
What? Subtract E, sorry.
E.
Dividing.
Well, it's dividing.
But it's
So coefficients are being divided. So what's the new coefficient going to be?
2.
Coefficient is 2.
And it's P2.
And then y, what happens to x? It's x to the 4th over x to the 4th, so that cancels. And then p squared. F is what operation happening with n's? What's the operation? They're multiplying. That means what are you doing with the exponents? Add them. So that makes this n to the power of 0. What's n to the power of 0?
1.
Okay. Now don't flip the page yet. This part that was on your paper, just put it a little bit lower. It got messed up. Let's go ahead and expand that. We just had a warm-up similar to this. What is the answer to this problem? 2.
Negative 1 over x2.
Okay. Cancel, 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 cancel. So x squared is left on the bottom. And what's on the top?
1.
Okay. What if we took this a different route? What if we took this the route of, it's division, so what do we usually do with division?
X minus.
We subtract them, right? So it would be 5 minus 7. Well, what is 5 minus 7?
Negative 2.
These are saying the exact same thing.
It's just x. It's just 1.
One is using a negative exponent and one has a positive exponent. So what's the difference?
So the top one is the correct answer.
Why is the top one the correct
There
answer?
can't be negative.
Correct. I never want you to write negative exponent as an answer. I always want positive exponents. So this one would be what I want on a paper. So then what happens if you do have a negative exponent? How could you make it a positive exponent? A negative exponent is representing an inverse of something, meaning you have to move it. So if it's a negative exponent and it was the top, the numerator of a fraction, it moves to the bottom. If you have a negative exponent in the denominator of a fraction, it moves to the top. Yes. So we're going to get to some examples. I'm going to skip all that fill in the blank stuff because we are. I don't like them. If you really need to see it, we can go back after some problems and I will fill all the words for you to make your heart happy and you can like that. But for right now, we're going to skip it. So the rule, this one is on your formula chart. A to the power of negative n equals 1 over a to the n. And it's just labeled as negative x. Nothing special. So we're going to look at number 5 first. That's going to be our first one to look at. On number 5, what are some things going on in that term? Addition. Okay, what parts can we add? We're multiplying and we have multiple p's. Okay, then let's do that. Let's multiply them. Negative 6 is still the same. What's the new exponent of p going to be?
Negative 3.
Negative 3, and then x to the 4th and y to the negative 2. So we went ahead and multiplied. That is not going to be good for an answer, though. I never want your answer with negative exponents. So which are the parts that have negative exponents? Y and P. So those are the two parts moving. Those are the two parts that still have to change. Negative 6 is good. That coefficient, it can be negative, it can be positive. Coefficients do whatever they want. You don't have to mess with those. It's just those negative exponents. So negative 6 is still in the numerator. X to the 4th is still in the numerator. And then both with the negative exponents have changed their location. Negative exponents have to change locations. Okay, we're going to do some more examples. So let's look at number 6. On number 6, do we have anything to simplify other than just switching some stuff around? Okay, so then that means we have one step. Just move stuff. What are we moving? Y to the power of 6. That means everything else stays where it was. M cubed, p squared, and now y to the power of 6 is on the bottom. Ta-da! Well, it depends. Where did it start? It's always going to be in the opposite place of where it started. So if it was on the bottom, it'll move to the top. If it was on the top, it'll move to the bottom. Correct. The only thing that ever moved is anything that had a negative exponent. If it has a positive exponent, keep it. Oh, okay. Let's look at number 7. On number 7, what are some things going on 7?
There's a negative on the top, but the same variable, but.
Okay, we have a negative exponent, and we have multiple of the same variable. That means we're going to have to do some like combining of bases, and we're going to have to do possibly some moving of things. What operation is happening essentially in that problem though? It's division. It has a division bar. If it's division, then that means what do you do with the exponents? Subtraction. Personally, I'm more inclined to make mistakes when it comes to subtracting in negative numbers. I just am. That's usually the one that I make a little bit of a mistake on. So when it comes to division, my personal preference is I like moving things than combining. Because I think it's easier to add things together. Now, if you don't care what order, this is where we're going to start getting into problems where what I do on the board might be different from what you do on your paper, but the end answer should still be the same. It's always going to be, it's still 2 steps regardless of which way you do it. So if we do move this first, that means we're going to have 6x to the 7 over 9g squared. M was there, and now it's m to the 5th. Now can we simplify some stuff a little bit? Okay. What about the coefficients?
Oh wait.
Can we simplify those coefficients? Yeah. 6 over 9, what's that fraction? 2/3. X to the 7, g squared, and m to the power of 6. Now, as you start getting a little bit more comfortable, maybe some of y'all didn't have to write what I wrote with me, but I would suggest, for now, save state, or like, just write small and show every step of your paper, on your paper. That way, if you go back to look at, like, wait, how did I get this answer so I understood in class, but I understand it now? If you show the steps now, it'll be helpful for me. So, let's do number... Oh, we don't have numbers. What about C? Let's look at example C. What's going to happen in example C?
6 is going to stay up.
Okay, 6 stays up, p to the power of 4 moves down. How about this? I want you guys, and let's just, you can work with your buddy, work with whoever's next to you. I want you to do E, G, and F, or EFT. First, look at F and E. I have the answers up here. E was a to the 7th over c squared n squared f to the 5th. F is 2p cubed m squared x to the 5th. Make sure, like, if you have different work, I might have done F differently than you did, but you have the same end answer. Okay. Now for G, because I kind of want to talk about this one. What operation is happening here?
It's multiplying.
It's multiplying and it has the negative exponents. Here's my personal preference. If we're dividing, I like to move and try and get rid of negative exponents first. If it's multiplying, I like to actually try and multiply and combine them first because sometimes negative exponents go away. I like avoiding that fraction bar until like the very end. I want to try and limit the division until the very end, if possible. So on this one, for me, I would want to combine these two first. Make that just one variable of n. So negative 7, n to the negative 2, n to the 4th, and x to the negative 3rd. Because sometimes, I know they combine to give you a negative exponent, but sometimes they combine and give you a positive exponent, which is less work for you. What will now have to move from this? We combined, everything has been simplified except for the negative exponents. So how are we going to change those negative exponents? Move them, which ones?
Down.
Which ones?
N and X.
N and X. So negative 7 n to the 4th over n squared x cubed.
Yeah, exactly.
So did you get the same answer? Maybe you took a different route. The more of these you do, and I know that this next page, the next page seems like there's a lot of problems. I promise. The more you do, the faster you get at it. It'll start going, not necessarily super quick, but you definitely start feeling more comfortable. Okay. Look at the bottom. On the bottom. So we haven't seen any of these yet. What happens if the exponent with the negative is in the denominator? We've talked about it, but we didn't do any problems yet.
Move it up.
It just moves up. So this will be 4 to the third. Nothing's left on the bottom, so that's over 1, which just means 4 cubed. What is 4 cubed? 64. Okay. What would the end answer be for number 2? M squared. What about number 3?
2.
This will move. Does the 2 have to change? No. So 2x to the power 4. Let's look at number 4. On number 4, what operation is happening? Division. Okay. Is that the only thing we're going to have to do? We have some negative exponents. Do we have any repeating variables? Okay. So again, my personal preference. If I have repeating variables in a division problem, I like to move those first. If you would prefer to do some other stuff first, you're welcome to. But I want to move all my negatives. Let's just take care of that part. So what are the negatives that are going to have to move? The negative exponents that are moving.
Wait, can't you already simplify this?
What do you mean? Well, no. Negative exponent and negative coefficient. We have a negative exponent on a coefficient. That means that coefficient has to move.
Oh.
So this is really saying 2 times 3 squared. We got to keep one m at the top, but now another m squared comes up there. X to the 5th moves to the bottom, and p got to 6. So there's our movements. It looks a little bit more complicated than what it is. All we have to do is just simplify and combine things here. M to the power of what? What am I going to have an exponent of? This is saying 2 times 3 squared. Well, what's 3 squared?
9.
So what's 2 times 9?
18.
And then x to the power of 5 and p. Yes. She was right here on the bottom already, and that 3 to the negative 2 had to move.
Oh, I moved it to the other.